Chapter 15, question 131. It is about addition reactions with cyclohexene. Cyclohexene is an alkene, so these reactions including polymerization also. Okay, I want to draw a very simple polymerization of alkene. I'm going to use ethene as an example. Okay, C2H4 looks like this. Now, if I have n number of ethene, okay, and just put them side by side, they will react with each other and form a polymer. Okay, dot dot dot. Yeah, a polymer that look like this: C C, okay, C C, H H. Now, no more double bond. Okay, double bond is broken, and new bonds are formed between the carbon. Between carbon in the monomer. Yeah, I'll just use red color to represent the new bond. Okay, so when you just continue like this, you get a polymer. Okay, again, many times. And right, so this is polymerization. Sometimes they can form a ring like cyclohexene one. Later we'll see in this um, answer number 1. So remember, yeah, no more double bond in the polymer, and a new bond is formed between the carbon that are uh, very close to each other between the monomers. Okay, now we have cyclohexene. Okay, looks like this. Now, if I have many cyclohexene together, okay, the same thing will happen, right? No more double bond, then there is a new bond formed between the carbon. So it could look something like this. Okay, no more. Okay, form a new bond. Okay, bonded to another carbon from the monomer. Sorry, no more double bond. Okay, sorry, my mistake. Okay, so this is the new bond. I'll put in red color. So can you imagine if you have like a different, okay, you have another one, then they can form, okay, they can form a compound like this. Okay, this, yeah, sorry, I'm sorry, not this. Okay, they said the double bond is here. It can also open up and then form. There are two bonds with these two. So this compound can be formed from cyclohexene. Okay, now let's look at the second one. Okay, I'll erase the whole thing so that we have more space. Now let's look at the second one. Now can you see that the second one is also very similar? You have the monomer, right? With the double bond initially here, 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 and here. Then after that, when they form, they are polymerized. Okay, they open up the double bond, no more double bond, and then form new bond between the monomers. So I put them in red color. Okay, these are new bond. Okay, now let's look at the third one. The third one, if initially the double bond is here, okay, then they all should be joined together and shouldn't be like this. You see now they have extra carbon in the middle, but here you do not have. Okay, the double bond is actually in the ring. So if they want to join together, there shouldn't be any extra carbon like this. Okay, unless you have, unless the double bond is not in between this. Okay, okay, unless you have the double bond outside of this and from something like that. Yeah, then probably it's more possible for this compound to form a polymer that is like this. So it is not cyclohexene, or maybe cyclohexene has reacted with ethene. So cyclohexene is not the only reactant to form a polymer in number 3. So the answer is 1 and 2 only are correct.